Welcome guys today and thanks for joining late evening. So I'm Shailendra Kadre as usual your host. So yesterday we finished our lectures on poison distribution. So including poison distribution we have finished total four distribution. One is normal distribution, then T distribution, then uniform distribution and poison distribution. So out of these four, my question is guys, which is for discrete one? Which is for discrete one out of these four?
Yeah, poison.
Poison.
Poison is for discrete one, right?
Yeah.
So if you know lambda, for any value of x, you can find out the probability. Simple formula is there, right? So you should know lambda. Lambda is nothing but the average rate you should know. Average rate. So if you are a airport manager or a bookseller, you know how many books you are selling per Saturday night on the average. Okay. So it's very easy data to collect. Average is a very easy data to collect. And if you are a airport manager, you know how many flights land in every 2 hours, right? You know that. It's a very common figure. So if you know that simple figure, how many average flights generally land me on my airport in 2 hours, I can determine that is my lambda, right? So with this value, I can determine the value of next any random 2 hours if I choose tomorrow or day after tomorrow. What is the probability of 400 flights landing in 2 hours or 300 flight landings in 2 hours? So if probability is high, I can prepare accordingly, right? So that is the simple Poisson distribution. So it is discrete. So we are counting events. So it cannot be a continuous number. It's events, number of events. So if we are counting events, your count has to be a discrete number. Okay, a whole number, discrete number. Now let us come to another distribution which is called binomial distribution. So binomial distribution you can say is a special case of Poisson distribution. Can you guys tell me Poisson distribution, how much should be the sample size yesterday, if you remember?
Greater than 20?
Yes, very nice, greater than 20. And in binomial distribution, it is reverse. Now, how much is the sample size needed for normal distribution?
30 plus.
30 plus. How much is the sample size needed for T distribution?
Less than 30.
Less than 30, right? Now, similarly, said like see, T distribution and normal distribution have a relation. If number of samples are more than 30, you use normal distribution. And if it is less than 30, you have T distribution. Curves are almost similar. So similarly, you have a relation between Poisson distribution and binomial distribution. If number sample size is more than 20, you go for Poisson distribution. If sample size is less than 20, we go for binomial distribution. Similar relation is there. Okay, that is one thing. Another requirement for binomial distribution is each observation should be independent. So each observation should be independent. It is the requirement of almost all the distribution, like every like binomial or any distribution you take, it is almost a requirement that every observation should be independent. Okay, now here special requirement for binomial distribution. Each observation presents only two outcomes. So there can be only two outcomes here, no three outcomes, only two outcomes. So two outcome means if I throw a coin, I can take head or tail. So either success or failure. If I call head as success, tail will be failure. Only these two observations can be there. Okay, and the probability of success every time should be same. Like see, if I throw a coin 10 times, what is the probability of getting head in all the 10 experiments? Tell me that. If I'm throwing 10 coin different times, so they are independent observations. What is the probability of getting getting probability of getting head all the time. Like in all the experiment, what will be the probability of getting tail, head or tail? Tell me.
0.5.
0.5, right?
Yeah.
So in all the 10 experiments, probability of getting head is same. So in binomial distribution, it is a requirement that only two outcomes should be there. High, success or failure, 0 or 1, or head or tail, these kind of only two should be there. And probability of success should be same in all the experiments. Like if I'm throwing if I'm throwing a coin, probability of success. Suppose if I called head as probability of success. So in all the 10 experiments, probability of getting success is same, 0.5. So that is a prime requirement of your binomial distribution. Okay. Then like in it's like in Poisson distribution, your n is large, n is greater than 30. It can go up to infinity. N can go up to infinity. But probability is very small. Probability is very small. Probability of occurrence is only less than 0.05. But it is reverse in the case of your binomial distribution. Binomial distribution n is small, less than 30 to 20. But probability is large uh, compared to Poisson distribution. In Poisson distribution, if you are applying, you will never get probability as 0.5 or zero point 0.6, whatever. You will not get this kind of values. You will get always get 0.1, less than 0.1, less than 0.05 in fact. So less than 0.05 probability only you will get. But in case of, see here, Poisson distribution, if we are throwing a coin, so throwing a coin is a binomial distribution. So it's a kind of binomial distribution. So throwing a coin, you are getting 0.5 probability. So 0.5 probability is something higher side. Okay, now the formula, you see the formula here. Don't get afraid by formula. Every probability distribution I said, like every probability distribution, as I said, only formula will be different. Rest all calculations will be same. Now here, probability of success at any point x, probability of success at any point x is given by NCX. NCX means combination. N combination x. NCX p to the power x. P is a success probability. P is success probability p to the power x. And q is failure probability. Q to the power n minus x. So what is p? What is the formula for q? Guys, if p is success, what is the formula for q?
It's a 1 minus.
1 minus p, right? Very nice.
Minus, yeah.
So now I want to know, like out of n events, total n events, I'm doing n experiments. Suppose out of, suppose n equal to 10. 10 time I'm throwing coin. What is the probability of me getting head 3 times? This kind of problem will be solved with the help of, like I'm doing n number of experiments, like n can be equal to 10, 20. Suppose I'm doing experiment 10 times, throwing the coin. How many times, like what is the probability of me getting head 3 times, success 3 times? So these kind of problems are solved with the help of binomial. So n is nothing but total number of events and x is nothing but probability of success. That's what we are calculating. So here, for any value of x, you can calculate, like you should know the number of experiment n, and you should know for how much x you want to calculate the probability. Okay, so with this formula you can calculate. Okay, so now if you remember your class 11th mathematics permutation and combination, if you know, so this is same combination here, NCR. We used to have it NCR, no? So it is nothing but NCX. Instead of R, we are putting X. So NCR is nothing but factorial n upon factorial n upon factorial n minus x and factorial x. That's what is NCR. So you can little bit load Google and try to find out. I say 11 class maths, so I am not repeating. So NCR is nothing but your factorial n divided by factorial x into n minus x factorial. So this is the simple formula for, and nowadays you are getting calculators which are directly calculating NCR. Integral also, whatever we are doing PDF. So in this case also, you are directly getting like integration also you can directly calculate. So NCR, NPR you can directly calculate with the help of. So now tell me, is this a discrete distribution or a continuous distribution?
It's a discrete, sir.
Is discrete, right?
Yeah.
Because we want to know out of n experiments, what is the probability of getting me x success, x number of success. Suppose I am doing n equal to 10, means 10 experiments. What is the getting my probability of getting 3 heads? So 3 is x, x is 3 here. What is my probability of 3 heads? So all are events, right? So all is counting only. So it is counting means all discrete distribution, right? Poisson distribution was also your Poisson distribution was also your discrete, and this is also discrete. But this is reverse of Poisson. In Poisson, sample size was more than 20. It can go very high also. And probability was very less than 0.05. Probability was very less. Probability of every event was very less than 0.05. And number of events were very high, less than 20. Greater than 20. Sorry, greater than 20. It is reverse. Now here, number of events are very less than 20. Number of events are less than 20, and probability is high compared to Poisson distribution. It is reverse kind of, but both are discrete distributions. So you can say that binomial distribution is a special case of when n is small and p is large, then we apply binomial distribution. Okay. Now here, you will ask me a question like, sir, why you need n less than 20? So if n is more than 20, if n is more than 20, say 400 or 500, if n is there, if number of experiments are 400 and 500, the value of this NCX will go very high. Value of NCX will go very high. You calculate. Suppose out of 400, you want to calculate what are the, suppose 400 times I am doing experiment, and I want to calculate what is the probability of me getting head 20 times. So 20 C, like 400 C 20, value will be very large now. Like, so value will be very large. So we don't prefer here high number of n, and we always prefer less than 20. So this is about now here, and Poisson distribution, like formula for mean and standard deviation are same. If you remember your Poisson distribution also, the formula for lambda is nothing but your mean is nothing but your mu. Lambda or mu is calculated by np. N is number of events and p is the probability of success. Sigma was give sigma square, like variance. Sigma square is nothing but variance. Variance was given by npq. N is number of experiments, p is probability of success, and q is nothing but probability of failure. Q is 1 minus p. So the same formula we used in Poisson also. Standard deviation will be equal to root NPQ. Same formula was there in Poisson also. Okay? So the formula for mean, variance, and standard deviation are exactly same as your Poisson distribution. So you have to remember less formulas. Only this formula is different. Main probability. So this will be a probability mass function or a probability density function, guys.
Density.
Anybody, any more answers? Guys, it will be probability mass function. Mass function because it's a discrete distribution. Whenever it is a discrete distribution, we'll call the probability function as probability mass function. And when it is a continuous number, then we call it as a probability density function. So in this case, this formula which is there in front of you is nothing but your probability mass function. Okay. So standard formula for mean, standard deviation, and variance are exactly same as your Poisson distribution. Okay, so this formula one more time given, so I'm not confusing you more. Now the difference between binomial distribution and Poisson distribution we already got. In Poisson distribution, number of experiment n is greater than 20, and in Poisson distribution, number of experiment n is greater than 20, and in binomial distribution, number of experiment n is less than 20. In Poisson distribution, value of probability of every event is very small, less than 0.05. But here in the case of binomial distribution, the probability is comparatively larger than probability values are probability of success p value of p is comparatively larger than with the help larger than compared to Poisson distribution. Okay, so like this is a relation which you should remember actually. So like there is one observation, this one observation we are studying. So we generally consider normal distribution to be pretty good approximation of binomial distribution. Okay. So now here we are talking about normal distribution. So when n into p, n means number of experiment, n is number of experiment and p is probability. The product of n into p is greater than equal to 5. Then we can say that binomial distribution and normal distribution are almost similar. So NP should be greater than 5. Now n is number of events, P is probability of success. So product of n into P should be greater than equal to 5. Then if it is greater than 5 or equal to 5, then we can say that binomial distribution and normal distribution are almost similar. Okay, so this is one observation. And see the right hand side. We have plotted here binomial distribution we have plotted for different values of n. N is number of trials. Number of trial means number of experiments. See, first the topmost is 100 trials. Then middle one is 400 trials, the curve. And the downmost, the below one is 900 trials. So you see the curve first was little bit coarse, like usually looking like curve is going smoother and smoother. Curve is going smoother and smoother. So as number of trial increase, so they are increasing up to 900 trials or 400 trials. Then n into p will be more than greater than equal to 5. So in such a case, there is no difference between a binomial distribution curve and a normal distribution curve. So is this understood, guys? Karthik, Amit, and Jignesh? Is this
Yes.
understood?
Yes,
Yes,
sir.
sir.
Simple things we are discussing right now. So this difference, I will not confuse you anymore. You can have a look at it when the slides are there with you. So let's share this. I think yesterday only I shared the slides, but once again I'll share today. So see the shapes of binomial distribution and Poisson distribution, just to give you an idea. Opposite kind of thing. Binomial distribution, it is left hand side tail is more, and Poisson distribution right hand side tail is more. So you know that Poisson distribution shape depends on heavily depends on the value of lambda. Okay, if lambda is large, Poisson distribution also becomes normal
Normal
distribution.
distribution.
And if number of trials and NP is greater than 5, then binomial distribution also becomes normal distributions. Okay. So these are the things to remember. And for academic interest, I have plotted so many different distributions here. See how gamma distribution looks like. It looks like a kind of uniform distribution. Then exponential distribution, beta distribution, binomial distribution, Poisson distribution, Bernoulli normal distribution. And like we are not going much detail into these, and only like whatever are important, that's what. But you see the shape. There are many distributions available, and many different shapes of shape of curve, distribution curve is available. Some are for discrete, and some are for continuous. So all kind of shapes are available for distribution curves. Okay. This is just for your academic interest. And then we take one example, for the binomial distribution, numerical example. Try to read on what is try to read with me, okay? What is there on the PPT? A box of candies, chocolates, a box of candies has many different color in it. When candies are there, so their wrappers are different colors. So there are many chocolates in or many candies in a box, and their wrappers are different colors. There is a 15% chance of getting pink candy. Pink is a color, you know. So if you randomly take out one candy, you don't look into it and randomly take out without you blind your eyes and take out randomly one candy. 15% chance that there is a 15% chance, means probability is 0.15 that you will get a pink candy, pink color candy. What is the probability that exactly 4 candies in a box are pink out of 10? Suppose now it has become little specific. Now he's telling that there are only 10 candies in the box. Only 10. So a number of n is 10. N is equal to 10. And he is asking probability that exactly 4 candies in the box are 4 candies out of that. Okay. So n equal to 10. What is 4 divided by 10? How much is the number? Can you find out from your calculator? I have a calculator here. So probability of success will be 4 divided by 15, which is equal to 0.26. Then how here 0.01?
No, 0.10. Sorry, 4 divided by 10. Na?
4, no, not 4 divided by 10. See, 4 is our x.
Yes.
Probability of success is given as 0.15. Generally, you taking pink candy,
Yeah.
probability of success is given as 0.15. It is already given.
Okay.
See,
So,
here.
yeah, understood.
15% chance of getting a pink candy. It is given. So probability of success is 0.15. So Q will be 1 minus 0.15, so 0.85. And x equal to 4. So now n equal to 10 and x equal to 4. And probability of success is only 0.15. So you have to find out the probability of finding x equal to 4 candies from 10 candies. So now just put in the formula. Yeah. So NCR. So like you put N, so NCR. So like let us see the formula here. So N, how much is N?
10.
10. X is 4. So 10C14. 10C14. 10 combination 14. That's what you have to calculate. P means how much is P?
P is 10.
0.15.
Sorry,
Right?
0.1.
What is the value of X? 0.15 to the power how much? X is how much?
4.
4. No. Yeah, X is 4. Okay. Now how much is Q?
Q is 0.85.
And what is N minus X?
10 minus 4. Na?
Yeah.
How much?
Yeah.
6.
6.
So now you can't you find out the probability?
Yeah.
See, if you don't understand how to calculate 10CX, 10C4, how to calculate, then you have to find out little Google. Okay. So I will tell you how to find that out. I will experiment for you. Like I cannot explain that in the class, but I will tell you. Like, see how to calculate. Just do this. 10C4. Okay. Like that, if you do, like how to calculate 10C4. Okay, find the value of 10C4. Huh? See, 10C4 means like give you the formula. Answer is 210. See, the formula is this. If you can read here. NCR formula. You can read the formula right here. Factorial n first of all. So factorial 10 on the top. Divided by n minus r factorial means n
10
minus 4 factorial 6. and then into factorial r means factorial 4. So factorial 10 divided by factorial 6 into factorial 4. That is how you have to calculate it. Got it, guys?
Yes,
Huh?
sir.
Yes, sir.
Yes.
So that's how you have to calculate it. And then other things are simple here. 0.4 to the power 0.15 to the power 4 you have to calculate. That you calculate by calculator. And then 0.85 to the power 6 you have to calculate. You put multiply everything. How much answer you are getting? Answer that you are getting is 0.04. So there is only 0.044% probability that if you are having 10 candies in a box, 4 candies will be pink. There is only very less probability. It is correct also, na? See, now he is telling if you take a general random candy, only 0.15% chance of getting a pink candy. Now here, suppose there are four pink candies in the 10 box, in a box of 10. What is the chance of getting pink candy? Suppose a box is given to you and there are 4 candies pink and 6 some other color. What is the chance of getting pink candy?
So 4% by
4%.
this scale.
No. 4 candies are there, na? So
Hmm?
10, only 10 are there, and 4 you are asking, like, what is the chance of getting a pink
40%.
candy? 4 are there, 4 are pink, and total are 10. So what is the chance of getting pink candy?
40%.
40%, right?
Yeah,
Na? 4
yeah.
divided by 10.
Yep.
But the actual chance given is 0.15 only. So now you want 0.15 is the actual chance of getting. But you want to calculate what is the chance of 0.4. 0.4 means 40%. So that will be very less only, right? If you calculate chance of getting 2 candies pink out of 10, then the chance will be higher because it is near to 0.15. Got it? Guys,
Yes, sir.
Yes, sir.
this is a very simple example. We'll take one more and then I think we'll close for today. We'll take one more. See, you are able to read what is there on my screen?
If
Guys,
x is
able to read?
Yes, sir. If X is
You read it.
binomially distributed with
Yeah,
6
if
terms.
I'll read it. Example, if X is binomially distributed, already given that X is binomially distributed with six trial and a probability of success is 1 by 4. N is given 6, N equal to 6, and probability of success P is given 1 by 4 at each attempt. What is the probability of getting 4 success? Now here N is 6, P is 1 by 4. What is the value of X in A case? What is the value of X A? What is the value of X in
25%.
case A?
X is 6 times. So 25% of 6.
I'm asking what is the value of X?
6.
6. No. In the case of X.
Four.
In case A, what is the value of X?
4.
4. What is the value of X in case B? At least 1. Means 1 and more.
One
How
and
you
more,
will do?
yeah.
Just 1 minus probability of 0. So you want 1 and more, right? So just deduct 1 minus probability of 0. You will get 1 and more, right? Got it?
Yes. Yes.
So now let us see when X is equal to 4, N equal to 6, and P equal to 1 by 4. So see, same thing here put in the formula. 6, 4 means it is 6C4. Probability of success 1 by 4, X is to the power 4. That is a X. Then 3 by 4, 1 minus 1 by 4 is nothing but your Q, 3 by 4. 3 by to the power N minus X. So N is 6, X is 4, so power 2. If you calculate it, it is coming 0.033. Now, second case is at least 1. At least 1 means 1 minus probability of 0. If I deduct probability of 0 from 1, I'll get 1 and more probability, right? Right or wrong, guys?
Right, sir.
So if you put in the same formula, NCR formula, you will get the probability as 0.822. You will get probability as 0.822. Okay. So don't go by their calculation right now. You do only this way only. NC 0, then P to the power 0, and then 3 by 4 to the power 6 minus 0. Like that, if you calculate, you will get 0.8. Don't go by their way of calculation. Put in the formula. So what will be the formula? N equal to 6, X equal to 0. So 6 is 0, P is 1 by 4. So 1 by 4 to the power X. So X is again 0. So 1 by 2 to the 4 to the power 0 into Q. Q is 3 by 4. So Q by Q to 3 by 4 into N minus R. So N is 6 and R is 0. Means X is 0. So 6. So like that, if you calculate, you will get the value 0.82. Guys, got it? So today I want to close at this, and let us keep it short today. Guys, you got it?
Yes, sir.
Yes, sir.
So like you know that what kind of problem you can solve with the help of a binomial distribution, right?
Yeah.
Like if you will be given a n number of experiments, you will be given probability of success as P. Then you will be able to find out of n how many are success. That's what you have to find out. That's what you can apply your formula. Formula is very simple here. Formula is here, given in front of you. Just apply the formula, you will get the answer. So n is nothing but your total number of experiments. X is the success you want to find out. P is the probability of success. X you know, and Q is the probability of failure, which is 1 minus P. Guys, got it? Binomial distribution.
Yeah, sir. And a real application where it be for binomial distribution?
Real application, you want me to tell real application? Let me find out one numerical example with real application.
Okay.
Tomorrow I will tell you.
Okay, sir.
Hai na? So I am
Yes.
not ready with that. But these are also real examples only. Like this is a real example. Pink candy. Okay, so candy is not a real example. So let me find out one real example for you tomorrow, and